So hopefully, because of everything we've done so far and your work in STEM class and dimensional analysis, this section hopefully is going to be super easy for you, I hope. Okay, so this section is writing and solving proportions. So proportion is an equation that states that two ratios are equivalent, right? We use that word a lot. We've actually already done these several times without me specifically saying, hey, we're going to write and solve a proportion now. A proportion is just two equivalent fractions set equal to each other, and you just have to figure out how to make them equal. That's it. Really easy. So think about the different ways you can represent 50 cents. Okay, if you're using pennies, it's 50 out of 100 pennies. If you're using dimes, it's 5 dimes that are worth 10 cents a piece. If you're using nickels, right, it's there's 20 nickels in a dollar, you need half of them, so that's 10 nickels. 10 times 5 is 50. If you're using quarters, it's 2 quarters out of the 4. Okay, we can use any of those pairs to set up a proportion, right? And what do you know? You know that cross products in a proportion have to be equal. So 50 times 4 has to equal 2 times 100. And 5 times 4 is 20, add on the extra 0, 2 times 100 is 200. That is mandatory in all proportions. So I want you to write this at the top. Cross products must be equal, right? You can always just cross multiply. Okay, really important. Okay, so here's a proportion. Now, if you have numbers, we've been doing this now for going on 2 months by the time you read these notes. When you solve this proportion, you have choices. Okay, if you have numbers that are related to one another, if they have a relationship, use that relationship to your advantage. Okay, so I know that I can get from 5 to 20, and remember that proportions, you're only multiplying and dividing. Nothing else, at least not yet. Okay, I know I can get from 5 to 20 by multiplying by 4. And I know that I can multiply 3 times 4 and get my answer of 12. Sorry, had a moment there. Okay, another thing that you can do is, let me rewrite this again, 3 times 5. And one of my students actually taught me this because they learned it from somebody else. And it kind of looks like a little fish hook. So you start with the pair that you have, and you multiply those together, and then divide by that. So you do 20 times 3 divided by 5. Okay? So 20 times 3 is 60, divided by 5 would give you 12. Same answer. And we're going to do a couple more this way. Another way that you can do that is you can simplify both fractions completely. Oh, I'm sorry. This section, you're trying to see how you can check those. Okay, to check, but we just kind of did that up here too. So there's 2 ways to check that you've solved a proportion correctly. And you need to check your work constantly. When you get in the real world, don't trust that others have done their work correctly. Make sure you've done yours correctly. And make sure you've checked their work to make sure that they're not, especially when it comes to money, shorting you money, not giving you the percent that you were told you were going to get, etc. Okay? So one way you can, if you know they're equivalent fractions, you know they must reduce to the same fraction. Okay, then they'll be equal, obviously. Okay, so 2 over 9, well, 9 can only be split up by 3 and 3, 2 by 2 and 1. So 2 over 9 is as simple as you can get that. 6 over 27, though, can each be divided by 3. So 6 divided by 3 is 2, 27 divided by 3 is 9, 2 ninths equals 2 ninths, so I know that that proportion is correct. The other way that you could always check a proportion is because you know this. Cross products must be equal. I'm going to highlight it again in a different color so we don't forget. It's going to be our mantra for a while. Cross products must be equal. Always, always, always. There is no exception to that rule. Okay? So if I cross multiply these, they better be the same amount. So 5 times 36 has to equal 6 times 30. Okay? So 5 times 30 is 150. 5 times 6 is 30. So total, I have 180. 6 times 3 is 18. Add the 0 on is 180. So 180 equals 180. Therefore, 5 over 6 is equivalent to 30 over 36. Okay? So now you're going to try some down below here. I want you to go way back to when we started fractions. All these are equivalent fractions. So if you need to go look back in your notes from when we did equivalent fractions and we had the little activity in class where you flipped over a couple of cards out of a deck and had to come up with 4 different equivalent fractions, we're right back to there. Same thing. Okay? So try that and then come back and check your answers. So, and I'm going to show you both ways. So 7 times 4 can give you 28. So 3 times 4 would be x equals 12. Or you can multiply 3 times 28 divided by 7. 7 goes into 28 4 times, and x would equal 12. Okay. Okay. So 8 times 5 gives you 40. 11 times 5 gives you 55. You also can, if you see that this is a reducible fraction, and that's getting quite a bit smaller than that, so I can take 7 out of each of those. So 49 divided by 7 is 7. 56 divided by 7 is 8. That's convenient because I'm looking for the numerator that goes along with 8 as a denominator. So my x value is 7. And then 28, if I need to get from 28 down to 14, I'm dividing by 2. So something divided by 2 equals 3, and that would be 6. I hope this is easy for you at this point, because you actually have been solving these proportions for a really long time without even realizing it. Okay, so writing and solving a proportion. You can use a table to organize the information for real-life proportion situations. And here we're going right back to dimensional analysis, where you've got labels and you're dealing with ratio tables. These are all the same thing. Ratio tables. Dimensional analysis. They are all intertwined because they all really are different forms of the same idea. Okay? So when you hear these phrases, don't get freaked out about the words. Just understand you know how to do all of this at this point. So, for example, Carol spends 17 hours in a 2-week period practicing her culinary skills. How many hours does she practice in 5 weeks? So, let's see the information that we need. So, 17 hours in a 2-week period practicing her culinary skills. How many hours does she practice in 5 weeks? So the one that we know she does 17 hours in 2 weeks. We're trying to find how many hours, so we don't know that, so let's use H, does she practice in 5 weeks? Well, right there is where you can set up your proportion, because you know that these have to be proportional to each other if she's using, on average, the same amount of practice time. Okay? So if you write that as a fraction, you would have 17 over 2 equals H over 5. And then you can do a couple different things. Now, 2 to 5 sort of has a relationship, but not really. 2 can't go into 5 evenly. So I'm probably going to cross multiply here. So I know that whatever 17 times 5 is has to equal 2 times something. So 17 times 5 equals 2 times the amount of hours. If I'm going to figure this out, I have to do the opposite of what's happening to it right now. So the opposite of multiplying by 2 is dividing by 2. So I'm going to divide everything by 2. So I would get 85 over 2, and that would be 42.5. Okay? So that's one way you can do that. The other way is to do the kind of hook thing where you multiply the pair that you have and divide the one you don't have, which is essentially what you ended up with right here, right? So you had H equals 17 times 5 divided by 2. And that is 85 divided by 2, which is 42.5. Now, I want to show you kind of a neat trick when you figure this out. So if now you're saying that 17 over 2 equals 42.5 over 5, I should be able to cross multiply those, right? Remember when we've been comparing fractions and all the rest of it. So 5 times 10 is 50, and 5 times 7 is 35, and added up, I get 85. Okay? 2 times 40 is 80. 2 times 2 is 4, and 2 halves make a whole, which is 1. 80 plus 4 plus 1 is 85. Both cross products are equal. I know I got the right answer. Okay? And that's it. That's your whole section on rates, ratios, and proportions, your whole unit. And really, all of what we've been doing up until this point, hopefully is going to make this section easier for you. Okay? Great job. Thanks.